17/39 and minus 4/39. Okay. Row 3 remains the same, so it's going to be 0, 0, 1. It's going to be minus 1/39. It's going to be 11/39. Okay. And it's going to be 2/39. Okay, so that remains the same. So what I need to do now is this: I need to add on. Whoops. Let me just move that. Okay. I need to add on to row 1 3/8 of. Oh, sorry, 3/8 of row 2. That should have been row 2 here. Okay, 3/8 of row 2. Okay, so let's see what happens. So the entry in here is going to be row 1's current value, which is a 1, plus 3/8 of row 2's values, which is a 0. So 3/8 of 0 is 0. 0 plus the 1 gives us a 1. What's going to go in here is row 1's current value, which is minus 3/8. But I need to add on to that plus 3/8 of row 2. So 3/8 of row 2 is 3/8 of 1, which is just 3/8. When I add that onto the minus 3/8, I end up with a 0 here. The value that's going to go in here is going to be row 1's current value, which is a 0, plus 3/8 of row 2's current value, which is a 0. So actually we get a 0 here. Okay? So you see we've got the identity matrix, but we need to continue our operations across on this row. So what we now have is, the next one is we have 17/156. This is row 1's value. So we have 17 divided by 156, okay, plus, well, we're going to have 3/8 of row 2's value. So 3/8 of 2/39. So we're going to have 3 divided by 8 is 3/8 times 2 divided by 39 is 2/39, which gives us a value of 5/39. So we have 5/39 here. Okay. Then what goes in here, okay, is row 1's current value, which is 55/3/12. And I need to add on to that 3/8 of row 2, which is 17/39. So we need to add, we need 50, oh, let me do that in brackets, 55 divided by 312, okay, plus, what I'm going to add on is 3/8, 3 divided by 8 of 17/39. So multiply by 17 times 39, okay, which gives us a value of, well, that's a little bit wrong, I think. Okay, let's do that again. Okay, so what we're going to have is we're going to have row 1's value, which is 55 divided by 312, okay, and what we're going to add on to that is we're going to add on 3/8, 3 divided by 8, okay, multiplied by row 2's current value, which is 17 divided by 39, okay, which gives us 53/156. So this is 53/156. That's more like it. And then our final value that goes in here, okay, is row 1's current value, which is 5/156. So let's put that in. It's 5 divided by 156, okay, plus 3/8, which is 3 divided by 8, okay, multiplied by row 2's current value, which is minus 4/39. So it's minus 4 divided by 39, okay, which gives us a value of minus 156. Okay, so minus 1/156. Okay, so what we've actually done now is this: is that we've actually converted. Okay, let me go back to the start here. Okay, we've actually through what's known as Gauss-Jordan Elimination and using elementary row operations, we've converted this matrix. Okay, through this augmented process, okay, we've converted this, we've done operations on this, but the operations we've done on this, we've also done on this, and we've converted this matrix, the matrix A, into the identity matrix. And what we're arguing now is this, is that this matrix here, okay, 5/39, 53/156, minus 1/156, 2/39, 17/39, minus 4/39, minus 1/39, 11/39, and 2/39. What I'm arguing now is this, is that that matrix actually is A inverse. Okay. Now I'm not going to do it now in this particular video because this video is running for 28 minutes. Okay, there was a lot of calculations here, but it's not unusual to try to find the inverse of a matrix and end up with lots of fractional amounts that don't look very friendly. Them fractional amounts. Okay, but what we could do now is we could take the matrix A and we could multiply it by A inverse, and we could show that it's equal to the identity matrix 1 0 0 0 1 0 0 0 1. You could do that. You could also take the matrix A inverse and multiply it by the matrix A, okay, and also show that it's equal to the identity 1 0 0 0, 1, 0, 0, 0, 1. You could do that. And maybe what I'll do is I will do that in the next video. Okay. So what we're going to do in the next video is we're going to verify that this matrix here, okay, is in fact the inverse of this particular matrix here. Okay. Okay guys, once again this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I do hope that this video was in some way intuitive, and more importantly I actually hope that it was helpful for you. The initial matrix A here looks very inconspicuous. Yeah, it doesn't look very complicated looking. They're all integer values, but we've seen that actually after performing this particular process, yeah, the matrix that we got looked a little bit unfriendly, yeah, in relation to that there was lots of fractions. Yeah, but it's important that we work in the world of the rational numbers, and when we get fractions that we don't convert them down to decimals. Okay, so once again guys, I hope that this was helpful, and thank you for watching. Okay, bye bye.